Hackers in general are spending a lot of time trying to figure out new creative ways to bypass static security controls. You don't have the staff or the time to try and stay ahead of that game. What can help, however, is intelligent decision making based on machine learning to identify high-risk situations and enforce MFA for user verification only when necessary. In this demo, we'll see how Centrify's risk-based access control uses behavioral analytics to stop in-progress attacks. The analytics engine builds a baseline of user behavior and leverages this dynamic approach for stronger identity assurance and to block high-risk access. So instead of MFA being on or off, all or nothing, it adapts to the situation and the behavior of the user to make more intelligent decisions while at the same time not bothering legitimate users with MFA. I'd like to begin by showing you where I'm currently located. As you can see, this site is reporting Santa Clara on the US West Coast in California. Here in the Centrify vault, let's navigate to my workspace where I've favorited the server I'll be using for this demo, TGDemo. I want to log into this server, so I'll bring up a list of available accounts and select the local admin account. Since the password is vaulted and I'm in my usual location, my behavior is considered low risk, and so I get single sign-on. Okay, now I'm located about 3,000 miles away in Secaucus, New Jersey on the East Coast. I've never logged in from here before, so the analytics engine won't see this as routine behavior. Let's go back to the vault and hit the login button again. Now, as you can see, I'm being prompted for a second factor of authentication. I'll pick the text message and we'll just fast forward through the video to approve this. And as you can see, I'm logged in again. Now, the policy I had previously configured said that for anything that's considered medium risk, prompt for a second factor of authentication to better assure the user's identity. Now that I've successfully responded to that second factor, the analytics engine will learn from that and adjust. So let's confirm that it has. So back at the login screen, let's log in again from the same New Jersey location. As you can see, this time we get single sign-on, no second factor. Due to the prior login, the analytics engine now sees this as low risk, not requiring MFA. As a final example, you can see we're now in Moscow, Russia. Let's repeat this test. I'll speed up the video. And as you can see, I've been denied access. This has been assessed as high risk compared to my normal baseline of behavior. The policy I configured earlier denies high-risk access attempts. Let's pop over now to our analytics dashboard for a bit more detail. I'll navigate to the Explorer screen where I can drill into individual events and investigate further if I want. I pre-created a custom query that will search for alerts associated with our demo user and with the Privilege Analytics service. So let's scroll down to the alert list for this user and expand it. First is the login from Santa Clara, assessed at a normal risk level, and therefore giving me single sign-on using my prior ID and password. The next two are the New Jersey logins, the first assessed as medium risk, but the second at normal, since I responded correctly to the prior MFA request. The last one is from Russia, assessed as high risk, where access was denied. So as we can see, static access control policies have their place, but it can be hard for IT security to maintain static policies and add new ones to accommodate other scenarios. With a risk-based approach and an analytics engine, we can take behavior into account, adjusting automatically over time as the user's routine changes.